Good afternoon, everyone, and welcome to my YouTube channel. So here today we are graphing modulus value functions. So how do we graph that one? So firstly, to introduce to you the knowledge about modulus values, we have let's say I am told to let's say graph. We have y should be equal to x. So in order for me to graph y is equal to x, I'll realize to say there is what we call the graph, the table of values. So I'll put, let's say if I put 0, y will be equal to 0. If I put 1, y will also be equal to 1 because this is y is equal to x. If I put a 2, y will be equal to 2. So in 10, if I am to graph this one, I'll have a situation of having a 1, a negative 1, negative 1, 1, negative 1. Let's say a 1, it continues like that, 2, negative 2, but this is just for the introduction, negative 2, positive 2. So from the table, I can establish that 0 will correspond with 0, 1 will correspond with 1 at this point, 2 will correspond with 2. Likewise, even the negative will follow suit like that. So if I'm to graph this equation, I'm going to have something like this. Now, here, let me use dotted lines because I'll change it. So these are dotted lines. So this is the equation of y should be equal to x, but it will be bold like that. But for the sake of explaining, I'll do this. So now, if I am told to graph y should be equal to the modulus of x, this is in turn what I'm going to do. The modulus value of a function will never produce a y value that is negative. Therefore, what I'm going to do is I'm going to rotate or reflect each point that is being negative. So like for example, y of negative 1, it should be positive 1. Y of negative 2 will be positive 2. So if I'm to join this, my graph should look like this. So these are the points of the modulus. So just a distinction in the color. So this means that this is y should be equal to, let's say if I'm to follow this line, this equation, this one is y should be equal to the modulus of x. So this one is what we are going to be calling the mother graph. So with this type of a graph, we are going to be able to graph any equation that we want. Likewise, this equation, this graph is the same as y should be equal to the modulus of the negative of x, because the negative of x, even if it's negative x, all the values will come out to be positive for y, meaning to say even if I was to do this, the graph would still look like the same. So for the same graph, let's say I am told to graph y should be equal to the negative of the modulus of x. If the negative is outside, this in turn will reflect each point. Now whatever is positive in this side, it will reflect to the negative. So the graph of y should be equal to negative of the modulus of x will look like it will look like this. So this would be our y should be equal to this one would be our y should be equal to the negative of the modulus of x. Each point is reflected. So just as you have seen. So now, with this knowledge, we are able to graph any graph using the method of translation. Let's look at our first question, which we have already done. Let's look at y should be equal to the modulus of x plus 2. So y should be equal to the modulus of x plus 2. So in order for us to graph y is equal to x plus 2, we are going to begin with our mother graph. So we have something like this. So our mother graph looks like this. It passes at 0, and also here it looks like this. So this is our y should be equal to the modulus of x. Now this means that if I add 2, same approach with the last video, we are just going to get x plus 2, equate it to 0. We are going to have x is equal to negative 2. So this x is equal to negative 2 means there is a shift in the x direction, which is at negative 2. So let's say this is negative 1, this is negative 2. So the graph, the origin of the graph was here, it is moved to here. So if we have that type of a movement, we are going to graph, so it is still the same graph, it's only that its position of the origin has changed. Likewise, since the origin has changed, even the intercept has changed, since we now have an intercept. So to find the intercept, we are going to say our y should be equal to, for the intercept, x is equal to 0, so we are going to have 0 plus 2. So here the absolute value of 2 is just 2, so meaning to say this point where it passes, it's a 2. So let me just make a solid line. So we have something like this. For this one will be, our y should be equal to the modulus of x plus a 2. So this is our graph for that one. Let's look at our next question. Just a reminder, if you have a plus 2 inside, that means to say it's a shift in the x direction. If it's outside, it's a shift in the y direction. So let's look at our next problem. Our next problem is saying that let's look at this one. The same one, we have y is equal to 2 by x plus a 2. So now what does this a number outside do? A number outside, it stretches the graph. You will find that your graph will appear to be more thinner. So for us to understand this one, the only best way for me to do this one is to solve it on the same graph so that you can see the difference. So this number such as a 2, it causes a stretch in the graph. So for example, all we are going to determine is the y-intercept. So originally the y-intercept was at 2. So now what is our y-intercept if we have a 2 outside? So we are going to have y should be equal to, we have a 2. For the y-intercept, we said that x is equal to 0. So we have 0 plus a 2. So y should be equal to 2 times the absolute value of 2. So this is the same as 2 times 2, which is equal to 4. So you will realize to say your graph, it is still the same shift. You can see that it's still x plus 2, meaning to say the origin is still at 2. So now for this one, the y-intercept is at 4, but the origin is the same. So to graph that one, let's use a different color. You will realize to say it will look like this-ish. I missed. So we have something like this, then it goes like that. So you will realize to say your graph has become thinner as compared to how it was. So this is y should be equal to 2 by the x plus 2. Likewise, it means to say if I have a number that is less than 1, such as let's say half, this one, let's say if I was to graph y should be equal to 0.5 by x plus a 2. For this one, it will cause a shift in the or it will make the graph to be more wider. This can be realized from the intercept. So to find the intercept for this one, let me just grab something. So to find the intercept for this, x is equal to 0. So we are going to have, for our equation is 0.5 for this equation. 0.5, where there is x, we are going to put 0 plus a 2, which will be y should be equal to, we have a 0.5 by 2, which is equal to 1. So you will realize to say your graph will become more and more wider as you move like that. Let me use the color blue. So we have a graph that is passing at 1 like that, passing like that, then it's also going like that. So this graph has become wider because of a fraction that is less than 1. So take note. So this graph is our y should be equal to 0.5 open or modulus x plus 2. So that is how we graph that one. So let's look at our next problem. Our next problem is saying that we have y should be equal to 2x minus 3 minus 1. So our C, which is saying y is equal to the absolute of 2x minus 3 minus 3 minus 1. Likewise, we are going to first find our shift. Okay, let's draw our mother graph. So we have our mother graph. We know that our mother graph looks like this, So this is our y should be equal to the absolute value of x. Then we are going to apply a shift. So we are graphing by translation. So we have the 2x minus 3, we are going to equate it to 0. So we have 2x should be equal to, we have a 3 over a 2 over a 2. So we are going to have our new value of x is equal to 1.5. So this 1.5 entails that our new origin will be at 1.5. So if this is 1, this is 2, in between those is where 1.5 is. So this will be our new intercept. So it will be more like that one, where we are going to have this one. So now for that one, we can label this one as our y should be equal to the absolute of x, which we know. Then this one will be our y should be equal to the absolute of 2x minus 3. Then we have minus 1. What does this minus 1 do? It's a shift in the y direction. It means to say each and every point. So first, let's find what our intercept for y is at that point. So at this point, we are going to just say our y should be equal to the absolute of 2x minus 3 minus 3. So we have y should be equal to, at the y-intercept, x is equal to 0. So we have 2 times 0 minus 3. We have y should be equal to the absolute. 2 times 0 is 0 minus 3. Then we have y should be equal to the absolute of negative 3. The absolute value of negative 3 is equal to positive 3. So here it will pass at positive 3. Now what this means is that when we subtract 1, we are subtracting 1 from every point. So to subtract 1 from every point means to say if we have a 3 there, we are going to have a 2. So here it will pass at 2 when we subtract this negative 1. So it will pass at negative 2 like that. Then this one, which is at 0, it will go at negative 1. So it will go at negative 1. So we have something like that. This value, it won't go below this. So we have a point that is here. So now it will be like that. Then it will also pass there. Let's use the color red. So that is where our graph will pass. Now, in order for us to know where the graph passes in the x, we are going to say y should be equal to, we have a 2x minus 3 like this. Then we have minus 1 like that. So this graph will pass at a point which is equal to, so if you look at this one, if we want the x-intercept, y is equal to 0. So we are going to say 0 should be equal to the absolute of 2x minus 3 minus 1. So we take the 1 the other side, we are going to have 1 should be equal to the absolute of 2x minus 3. Now each and every time we find the absolute of any number like equal to the positive there, we are going to introduce plus or minus 1, which is equal to 2x minus 3. So either 1 should be equal to 2x minus 3, which will, or we have negative 1 should be equal to 2x minus 3. So we find the values. If we find the values, we have 1 plus 3 should be equal to 2x. So we have 4 should be equal to 2x over 2 over 2. Our x is equal to 2. Or we have negative 1. We throw the negative 3 here. It will be plus 3 should be equal to 2x. Then we have a positive 2 should be equal to 2x. We divide 2, we divide 2, our x is equal to 1. So this graph passes at 1 and 2. So we have 1 and 2. So it passes this point and this point, then it connects to 2. It will be a bit difficult to draw the straight line. So we have the graph that looks like that. Let me just move the point 1 a bit. Yeah, so this is our graph of y should be equal to the absolute of 2x minus 3 minus 1. So for our last example, we are going to have y should be equal to negative of x plus 2 minus 3. So we have y should be equal to negative of x plus 2. Is it minus 1 minus 3 minus 3. So likewise, let's draw our mother graph. So we have a situation of this. So our mother graph looks like this. So this is our mother graph of y should be equal to the absolute of x. So instead of doing all this, what we can just do is, now this negative reflects the graph just as we did. So we can show the graph being reflected like that. So this is a reflection. This graph, we called it y should be equal to the negative of the absolute of x, so that it matches the equation. Then we are going to apply a shift. So the second graph we always follow after the first, the second, the third graph will more like be our x plus 2 should be equal to 0. So our x will be equal to negative 2. So this graph will start at negative 2. So we have a negative 2 here. So this will be our new starting point of the graph. Let me use a different color. Our negative 2 there. Then we are going to go at the intercept. So which one is our intercept? So we need to find that. So we have y should be equal to the negative of x plus 2. So to find the intercept, x is equal to 0. So y should be equal to negative. Then we have 0 plus 2, which should be equal to the absolute of 2 is 2 times this negative. Our y value will be equal to negative 2. So the graph will pass at negative 2, which is here. So we are going to have our graph to look like this. So this is our third graph, which is our y should be equal to negative of x plus 2. Then when we finally go to our last portion of the graph, we are going to move it 3 units down. So this is a downward shift or shift in the y. So we have, if it is at negative 3, it will move at negative 3. If it is at 0, it will move at negative 3. So we are going to have, so each point will be moved 3 units down. So if it's at 0, it will go at negative 3. So this one will be our new, more like the turning point or the origin. Then this intercept, which was at negative 2, so we are going to have negative 2 minus the shift of negative 3, which will give us a negative 5. So we are going to go at -5, which is this point. So the -5 will be at that point. So we are going to connect the graph. So we have a graph passing at that point like that. Then we also have the graph like that. So this graph will be, our y should be equal to negative of x plus 2. Then we have -3. So that is how we do such graphs. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.